separate and solve the ODE if possible. All right, so we're going to try and separate this, and we've written the dy dx as, y prime, not y prime, as dy dx. And we're going to try and get all the y's on one side and all the x's on the other, including the dx and the dy. So this doesn't look too bad. A lot of times these problems are fairly straightforward to separate, or they're impossible. So we're just going to multiply both sides by y and dx. So if we multiply each side by y, that'll cancel the y on this side, but we'll end up with a y dy on this side. And then if we multiply both sides by dx, we'll end up with canceling the dx here, and we'll end up with 1 plus x squared plus x squared dx. All right, and then from there, we're just going to integrate both sides. So integral of 1 plus x squared dx equals the integral of y dy. All right, so the integral of 1 plus x squared, that ends up being the 1 turns into an x, plus x squared turns into x cubed over 3. And then there is the constant of integration to remember. And on the other side, if we're integrating y with respect to y, then that's going to be y squared over 2. And the constant of integration we're not including on this side because we included it on the left-hand side. So now the next step is just to solve for y. So first I'm going to rewrite this a little bit. I think I'll go over here. So I have y squared over 2 equals x plus x cubed over 3 plus the constant of integration. That's just so I can solve for y on the left-hand side. So first I'll just multiply by 2, so I get y squared equals 2x plus 2 thirds x cubed. And then there's plus 2c here, but I'm just going to absorb that 2 into the c, because 2 times a constant is still a constant. So 2x plus 2 thirds x cubed plus some constant integration. So now we have y squared equals this thing. So the last thing is to do a square root. So y equals, we have to remember the plus or minus, square root 2x plus 2 thirds x cubed plus c. And right, in order to pick the plus or minus, that's going to depend on what the initial condition is. And we don't know that here, so we're just going to leave it as plus or minus. But that's the idea. So there's this clever notational trick to kind of treat the dy and dx as a fraction, which you're not really supposed to do, but it ends up working out. There's a video at the end of the playlist to explain that. But it's very convenient and it works. And as long as you can separate, which doesn't always occur, then it's a fairly straightforward way to solve first order differential equations.